So hello everybody, I'm glad to be here in Prague talking about Elastic Kubernetes. So actually before we start, I would like to ask, are there any Kubernetes users? Raise your hand. Yeah, so almost everybody. Perfect. DevOps people maybe? Who is DevOps or consider themselves DevOps? Developers? Okay, cool. Okay, so, because we will gonna spend some time together, so I would like to know you. So now about me. So my name is Zbyněk Roubalík. I am Microsoft MVP. I have many years experience with Kubernetes, open source stuff. And why I'm here today, I'm a maintainer of project KEDA, which is open source project that tries to make Kubernetes application autoscaling as simple as possible. So this is the reason why I'm here. And finally, a few months ago, we launched a company around Project KEDA, which is called Kedify. I'm the founder and CTO. And we basically try to use this open source project, it's a CNCF project, to provide enterprise platform for autoscaling for customers. So basically, more relevant stuff and anything, what you can imagine. We just started, so actually, if you are interested in about Kubernetes, about something about maybe APIs and controllers and all this kind of stuff, reach out to me because we are hiring at the moment. We are a US-based company, so there is some money actually in the company. So, so whatever. Okay, let's go. Okay. So why Elastic Kubernetes? Why is it so important? I think that these times when we are talking about platforms, the applications, cloud, whatever, we really should consider to bring elasticity into the platform because we need to save costs, right? And also we would like to be sure that the application is responsible and available all the times. So basically, imagine we have plain Kubernetes cluster and we would like to deploy some application on it. And maybe there are, let's say, two main issues that could happen with the application. So the first is under-provisioning. So basically, we have not enough resources in the Kubernetes cluster, and when users are using our cool application, maybe the application is not doing well. They have glitches in the UX and all the latencies and all this kind of stuff. Or we can over-provision. So basically, we have our Kubernetes cluster, and we are spending too much money on the cloud resources. This is also, something we would like to avoid because, money talks, right? So we would like to really save money. So we really should think about to bring elasticity into our platform because we can easily solve this kind of two problems at once. So basically, if the application is needed, we can easily scale it out, or if it is not needed, we can scale in and save costs. So this is the main stuff about the elasticity on Kubernetes. And how can we do it actually? So there are, I would say, two layers. So the first layer is application autoscaling. So basically, we would like to scale out our applications based on demand, based on some external metrics, based on the utilization. And imagine that we have Kubernetes cluster. For example, it has 2 nodes, and we are gonna spend, I don't know, maybe we are gonna have maybe 40 pods running on the cluster. And as we are scaling out, the cluster with some autoscaling solution, then we may face issue with the infrastructure. So we might also scale the cluster underneath. So this is kind of like this indirect relation or something. So basically, the application autoscaling is making a push on the cluster autoscaler to actually scale the whole cluster. So we really should think about in these 2 layers. It is not just about cluster autoscaling or just pod autoscaling, but these both things in together. But also there is this indirect stuff. Why? Yeah. So on the left-hand side, actually, on the yellow part is let's say the resources that we have defined in our clusters. And the red represents the requests coming to application. So in this case, we can see that usually we are over-provisioned. In the middle, we can see that we are slightly over-provisioned. If we bring the elasticity into the solution, we might see something like this ideally, right? This is ideal use case. So basically, that the resources, let's say, follow the requests. Okay. So. Just before we go into actual stuff, I would like to maybe talk about a little bit about the resource request and limits. This is important stuff on Kubernetes. Many people, don't think about it properly. because every workload has different set of requirements. So each workload is different. We have this big Java application, maybe we have this small Go microservice or whatever. So really, we should think about what is the specific resources that we need for the specific application. So we should really think about setting always set resource requests and limits only for memory. Setting limits for CPU is not a good practice. There are a lot of blogs written about it. So really think about this solution. And the important question is, how can I set the correct resource requests or limits for my application? How can I do it? I can give you the right answer because every workload is different, right? So the best way is basically to collect metrics over time from our platform, and based on the metrics collected, we can set and maybe change the request regularly. Okay, so also, what is requests and what is limits? So resource requests in Kubernetes means that is the minimal amount of resources needed for a pod. So basically, if we create the pod, Kubernetes scheduler needs to assign this pod to a Kubernetes node that fulfill this requirement. And resource limits is the maximum amount of resources that this specific application or pod can use. So really think about these two settings. This is just I don't want to go into details into the graph, it is so complicated, but I just want to mention Kubernetes scheduler. Why? Because if we are talking about application autoscaling, in the end, application autoscaling, what is it? It is just creating new pods, new replicas. It is not something magical. So when we are autoscaling the application, we are just creating new pods, and then Kubernetes scheduler need to put these pods into specific nodes. So there are certain stuff in the Kubernetes scheduler, and we really should think about it. If I schedule more pods, the Kubernetes scheduler will just need to place them somewhere. So this is really the stuff that matters. Okay, so this was just very brief introduction. I think that a lot of you already know these concepts, but I would like to quickly go through them so we are on the same picture and maybe can discuss that later. So horizontal scaling. What is horizontal scaling? With horizontal scaling, we are increasing or decreasing the number of replicas of our pods. There are some, how to say it politely, whatever. So when we are scaling horizontally, we should be speaking about scaling out or scaling in, not scaling up and down. Yeah, so it is scaling out because we are creating more replicas of the very same application. So so the resources, limits, and requests on the application doesn't change. We are just creating more replicas. This is a horizontal pod autoscaling, pod scaling. How we can do that? We can do it manually, right? So we can just run, this command, kubectl my application to 5 replicas. It will create 5 replicas. Kubernetes scheduler will place them on specific nodes, or we can do it declaratively through the YAML file. Simple. But we would like to do this automatically, so on Kubernetes, it's well-known horizontal pod autoscaling. It's a built-in Kubernetes component that this job. So basically, it scales our replication based on some metrics. And the metrics are, so basically, imagine a situation. We have Kubernetes application, this is deployment, and the application is performing some expensive tasks, so it is taking a lot of resources. So what actually HPA is doing, it monitors this specific resource, and it checks the utilization of the resources. So the stuff I was talking about just a couple of seconds ago. So basically, it is checking the CPU or memory consumption, and based on that, it scales out the application. This is useful for many use cases. This is perfect because our application is not able to maintain the load, so we need to scale it out. So perfect. This is very simple. What do we need to enable like a horizontal pod autoscaler? We need to enable a Kubernetes metric server on our Kubernetes cluster. So it is basically the aggregator of resource data. And with Horizontal Pod Autoscaler, we can schedule, we can autoscale any deployment, stateful sets, or custom resources that expose a scale sub-resource. It is like a small sub-resource that we can use to directly. If you want to use Horizontal Pod Autoscaler, you need to specify resource limits requests. There are different types, metric types with HPA. So the built-in types is CPU or memory. This is the stuff I just described on the example before. So basically this is simple. Based on CPU memory consumption, we are scaling out. Also, what HPA supports is called custom or external metrics. And it is some metrics that are not directly in the application, but we would like to collect some metrics from some external system, and based on that, do the decision. Actually, like the difference between custom and external metrics, It is just formal, I would say. Nobody actually makes the difference between those two. So originally it was intended that the custom should be for in-cluster metrics and the external for a cluster, metrics from outside the cluster. But it is under the hood. This is the very same stuff. With HPA, it's important. You cannot scale down to 0. So basically, if you would like to do this, you cannot scale to 0. Because imagine that if you are scaling application based on CPU or memory consumption, once you scale to 0 replicas, you don't have the application, so you don't have the source of metrics. So now you don't know when you should wake up the application. So this is very important stuff to think about. This is just the example of how HPA is working. So basically, it is using this very, very simple algorithm. So it is checking the current metricas and the current metric value that we are getting and checking the desired metric value. So basically, we are saying that the threshold for our application is, for example, 5. The current metric is 15. So we would like to divide this across all the pods. Simple, nothing complicated. Also, just to give the full picture. On the right-hand side, you can see the example of HPA. So basically, you define your minimum, maximum replicas, the type of metrics that you would like to use. So in this case, it's CPU, utilization, and your target my app deployment. You can define multiple metrics, simple stuff. Okay, so this is HPA. Now let's talk about vertical pod scaling. What is vertical pod scaling? In this case, we are talking about scaling up and down. So basically, we are increasing or decreasing the amount of resources assigned to our pod. The number of replicas doesn't change. So let's say that we have this application, it has 1 CPU, 1 memory, and we would like to extend it to 3 CPUs, 10 memory. This is vertical scaling. Also, we have Vertical Pod Autoscaler on Kubernetes. This is not built-in stuff. We need to install it separately, but it is part of the Kubernetes, let's say, space. So you can install Vertical Pod Autoscaler that does this kind of thing for you automatically. So again, the same example. In this case, again, the same application performing some resource-expensive task. We plug VPA. It monitors the same stuff utilization, and based on the utilization, it try to resize the application. Also, so the important stuff. So a Vertical Pod Autoscaler determines the resource limits and requests based on the historic, let's say, and current metrics. So it is checking to the history and metrics and try to do, like, let's say, prediction. If we decide that we would like to change the actual amount of resources assigned to our pod, containers may be rescheduled. So basically, our application will stop, and the Kubernetes scheduler will try to create a new pod or maybe on different node. So we should really think about this let's say, this downside of this approach, because it is hard to resize the application on the fly. We should think about that we shouldn't use this together with HPA, because if we use HPA and VPA for the same resource, those two autoscalers will fight against each other, and we won't see like the perfect solution. The VPA has 4 modes. So let's say there is an auto and a recreate mode. So the recreate mode, basically, if VPA decide that it would like to change the resources requests specified on the application, it will create a new pod with the new settings. The auto will try to resize the application actually, like on the fly, but maybe it won't succeed, but it will just try to resize the application on the fly, so we don't see any let's say, any interruptions in our application that is running on there. What I would actually also recommend is to use just the initial mode, that it will initially just apply these recommendations. So during the pod creation, it will initially try to put some kind of right settings. And the very basic stuff is the mode off, and it only provides recommendations. And this is, I would say, the most useful stuff for you. So if you would like to right-size the application and you would like to specify the right moment for redeployment of the application or whatever, this mode gives you just the insights into metrics, and it could tell you, okay, this is the proposed or whatever suggested resources that you should set on your application. So I would definitely recommend starting with this one. It will give you the right overview on how you should set your application. Again, just a brief look into architecture of VPA. There are 3 main components. So the recommender, it monitors the resource utilization, and based on that, it computes the target values. So basically, it does the majority of stuff. And then there is the updater. So basically, if we decide that we should change the values, the updater will try to create a new pod with these new settings, or maybe we'll try to just resize. Admission plugin is the let's say not so important component. It just checks that we are setting the correct stuff on the thing. So basically, VPA is trying to check the same metrics as HPA, but it just tries to give you insights on the container. This is the example. So on the left-hand side, you can see the VPA. So basically, in here we are setting. Let's target this deployment, and in this case we have the mode off, which is just the recommendation. So on the right-hand side, you can see the actual recommendation from this VPA setting. So in the status, we can see that for our container, we can see some lower bound, upper bound, and target. So basically, based on these settings, we can right-size our deployment without any interruptions. So this is VPA. So basically, we covered HPA and VPA, the very basic stuff on Kubernetes. It all works on, let's say, memory utilization or CPU utilization. Now, something more interesting. So demand-based autoscaling. What is it? In this part, we will talk about Project Knative, and in specific about Knative Autoscaler. It's also a CNCF project. And so what are we trying to solve with this approach? So imagine an example that we have application that is not computing some hard task or whatever, but it is serving HTTP requests. So basically, based on the number of incoming requests coming to our application, we would like to autoscale this application. You cannot do this with CPU or memory, because CPU or memory consumption doesn't always correlate with number of incoming requests, because processing the request might be very fast, very not so depending on the consumption of the resources, but we need to do it fast. So basically, we would like to do this kind of case of scaling. With HPA, we cannot do this, because HPA just directly checks the application. So what we can do to solve this problem, we can use Knative. So in this case, we have the very same application, but this time it is not deployed as a Kubernetes deployment, but it is deployed as it's a component called Knative service. It's like the building block for the Knative applications. So basically, just simplify the deployment. And in this case, what Knative can do, it can monitor this application and can monitor incoming traffic to this application on the let's say HTTP-based requests, and based on that, it scale out the application. So it works very fast. The downside is that we need to rewrite the application or redeploy the application from Kubernetes deployment to Knative service. In this case, it works perfectly. So, as I mentioned, what are the main concepts of Knative Autoscaler? So we need to scale Knative service. So it is like a custom resource that represents a workload. And actually, it's like a simplification of Kubernetes deployment. So in the one deployment, you specify all the things you just put there. For example, container, and all the resources needed as a deployment, Kubernetes service, or ingress will be created for you automatically. And then there is an activator component that enables you to scale to zero. Because scaling to zero for HTTP requests is a hard task. It is not something that you can solve easily. Because imagine if you scale your application to zero, and now the request is coming, you would like to not lose the request. You would like to somehow process it by the application. So an activator component works this way. So basically, it waits for the incoming request in case the application is scaled to zero, holds the request until the application is scaled at least to one replica, and then forward the request to our application. There are many stuff about the autoscaler. You don't need to go into details. This is fine. And basically, this is how the algorithm. I don't want to go into this because it is so complex. I don't understand it. But I just want to mention that the autoscaler is, I would say, more smart than we can think about. There are some settings that enable you to handle like a burst of incoming requests, or all the stuff. So you can specify all the stuff you would like to do. So basically the blue line is the number of replicas, and the yellow represents the coming requests, and we really can tweak the settings very, very heavily. So there is a lot of configuration for autoscaling. Also, example how this stuff looks like. So on the right-hand side, you can see Knative service. So this is as I mentioned, the building block. So in the Kinetic service, you just specify, okay, use this image and expose port 8080. We can deploy it through CLI or through YAML file, and Kinetic will create all the stuff for us automatically. Okay, so this was request or demand-based autoscaling. And now event-driven autoscaling. So in this part, I would like to talk about Project KEDA. I'm the maintainer of the project. And we try to really make like this Kubernetes event-driven application autoscaling as simple as possible. Also a CNCF project. So what is the problem that we are trying to solve? So this time, imagine an application that is consuming messages from, for example, Kafka topic or RabbitMQ or any similar, let's say, queue-based system or messaging system. If we would like to autoscale this application, what are on Kubernetes? What can we do? We can use HPA, but again, with HPA, we can just scale with CPU or memory. And in this specific example, really, like the CPU or memory consumption doesn't correlate with the actual need. Because, for example, imagine that you are consuming the application from a Kafka topic, and in the topic there waits, for example, 100 messages waiting to be processed. And we really want to autoscale the application based on this number, not the number in the application. So with HPA you cannot do this because HPA monitors the stuff. So what we can do, we can plug KEDA in, and we don't have to change the application, nothing. The application is the very same Kubernetes deployments. Actually, the application doesn't know anything about that KEDA is there. And what KEDA does, KEDA scrapes the metrics from the external system. So scrapes the metrics about the lag in the Kafka topic in this specific example, and based on the number, it does the decision and scales the application. Under the hood, it is using HPA to do the actual scaling decision. But all the framework around we are trying to solve from KEDA side. So as I mentioned, KEDA is an open source project, CNCF one. It started actually a few years ago as a cooperation between Microsoft and Red Hat. So we tried, I was in Red Hat back then, and we tried, this POC internally about this project because we tried to solve this specific problem, and the project, was well. So we decided to open source it and then donate it to CNCF. At this moment, we have 65 plus different scalers. So the scaler, you can imagine, is the service that can talk to some external stuff. So in the example before, it was Kafka, but we have Prometheus, Metrics, RabbitMQ, all the AWS services, Azure services, Google services, whatever you can imagine. And if the scaler is not there, you can also use this concept which is called external plugin, external scaler. So it's basically a gRPC interface where you need to implement just 2 or 3 functions or methods, and you can have your own proprietary scaler. So, for example, if you have some proprietary stuff in your company and you don't want to expose it, you can build this scaler in a separate container and just connect it to KEDA through this interface. And based on that, we can just feed the metrics into KEDA, and KEDA will handle all the stuff around. So we are really scaling based on events or custom metrics happening outside of the application. Also, what is the benefit? At this time, we can scale to 0. HPA cannot scale to 0, but with KEDA, we can scale to 0 because we have like this outsider's view. So we are not looking at the metrics that are in the application, but we have the different source, so we can scale to 0. And important stuff to mention, KEDA does not manipulate the data. So as I mentioned, the application doesn't know anything about KEDA. It doesn't need to know, because why? We just scrape the metrics from the system, and based on that, we are autoscaling the application. Just quickly about the architecture. So KEDA is built on top of Kubernetes. So in this project, we are trying to not reinvent the wheel. We are trying to use all the stuff that's in Kubernetes. So I would say there are 2 main components. So this is the controller, the box inside, and metrics adapter. So the controller is basically an operator or Kubernetes operator that manages the KEDA resources, and based on that, it opens connection to the external system. So, for example, in the Kafka example, it opens the connection to the Kafka and reads all the metrics. And the metrics adapter takes these metrics and feed them to HPA. So then HPA can do the decision. What the KEDA controller also does, it does the 0 to 1 or 1 to 0 scaling. So we call this activation phase. So basically, if you scale your application to 0, you would like to activate the workload. You cannot do this with HPA, but you can do it with KEDA. So KEDA basically activates the workload if needed, and then from 1 to n amount of replicas, the HPA is taking over. The HPA is created for you automatically. You don't need to do anything. Really, what we try to do with this project is to make it really user-friendly. So to do that, we have defined a bunch of resources. The main resource is called scaled object or scale job. In these objects, we define the scaling metadata, and based on that, the controller, do all the stuff. Okay. So this is the example of the scaled object. On the right-hand side, you can see the scaled object is very simple. So you can just specify the target workload. Again, it could be deployment, it could be stateful set, or it could be any custom resource. You just need to expose scale sub-resource. So for example, Argo rollouts, if you are using Argo rollouts, you can use it directly with that. Then we need to specify the minimum maximum replicas, and then at the bottom there is like the important section, which is the triggers section, and in this section we can specify the actual target services or target metrics. So in this case we have just one trigger, which is the Kafka. So we just need to specify the Kafka broker URL, the consumer group, and the topic, and the threshold. So in this case it's 5. So it is doing the decision based on 5 unprocessed messages in the Kafka topic. You can specify multiple triggers in the same scaled object. Also, I would like to highlight, when you are autoscaling on Kubernetes with HPA or KEDA, or maybe just together, please just specify only one resource per workload. If you specify, for example, multiple HPAs for the same deployment, it wouldn't work because they will be fighting each other. Also, if you have, for example, scaled object and HPA together, no, please don't do that. Put all the stuff into single resource. So for these purposes, we also support like the CPU or memory scalers. So basically, this is just the wrapper around HPA. So if we go back into the specific use case, so for example, imagine that we have the example, I would like to autoscale my application. What I need to do, I just need to create a scaled object. So I create a scaled object. The scaled object is here. It is being created in Kubernetes API service. We have the controller, the operator. It is notified that there is new resource. It checks all the settings that are correct, and if they are correct, it opens the connection to the Kafka broker, and it will also create the HPA for us. So it will generate the HPA for us that will understand the metrics that we are going to feed into the HPA, and then the autoscaling happening. So if there is no load, the KEDA operator will scale the application down to 0. If it generates some load, the operator will scale to 1 replica, and then, because we are using Kubernetes, the HPA will be notified that this workload has been scaled to at least 1 replica, so it is live, and it will start requesting metrics for this workload, so it can do the decision. So actually, we are not sending the metrics to HPA, but the HPA is asking us for the metrics because we are using this common endpoint in Kubernetes. And this is also important to mention because HPA is asking for the metrics periodically. It's called like this polling interval. So every 15 seconds, by default, on major Kubernetes clusters, it asks for new metrics for the workload, and we really have no means how to change this solution. This is cluster-wide setting, so we should consider about this interval when we are designing the application. So this is the HPA. Scaled object and scaled job. This is another like the main resource for KEDA. And this time we are actually not auto-scaling, but we can schedule Kubernetes jobs based on events. So this is useful if you would like to handle some workload that is processing some long-running executions, maybe hours, days, or so. So imagine if you deploy this workload in deployment, based on some metrics, it will be scaled out to some replicas, but the application then will start processing the workload. But HPA may kill it after some time because it will think that it is already like the metrics have been already solved. So for these use cases, we really can use this resource. It is very same as the scaled object. So basically, instead of referencing the deployment or workload, we can just put the whole Kubernetes job definition in here, and based on the metrics coming from the Kafka, it will create Kubernetes jobs. So it will try to solve this let's say this threshold on the topic, and based on that, it will create new Kubernetes jobs to process these executions. Another important thing I would like to mention, or let's say highlight, is that We have also like a resource, it is not listed here, that you can define, let's say, your authentication, authorization stuff in single place. So, for example, you are administrator in the cluster, and you can define multiple stuff because usually when you are talking to these external services, you don't want to use connection without any authentication authorization. So we have like this resource when you can specify this in the single place. It supports Kubernetes secrets, or vaults, or managed identities, and just reference it in your Scala job.